All right, this is the simulation for Coulomb's law. The purpose of this activity is to observe how charge and the distance from those charges are going to affect the forces between them. So you can see here there are some references. There's going to be the simulation, that's the simulation off to the right. There's also going to be this video, and there are a couple of other videos that will help you out, just about just about the inverse square law and the electrical charge. First thing that you want to do, you can see here, just use the instructions. Once you pull up the simulation, sometimes it comes up macro scale or atomic scale. We want the macro scale. So I'll go ahead and shrink this down so we can see all of the settings. So all of them start with a picture that show you what to do. What we want is we want to move this Q1 all the way down, and we want to move Q2 onto the 5 centimeter mark for this first one. And we also want Q2 to be to start at 0. So what we're going to do in this one is we are going to gradually increase the charge on Q2, and we are going to see how that affects the force. So the first one, you can see it's already up there. It's 0 newtons, right? Because there's the charge on Q2 is 0. So I'm just going to put 0 here, right? All right, perfect. You can see here a graph. I'm just going to show you what it looks like. We're going to increase it by 2 every time, 1, 2. And now the charge, or the force is going to be 28.76. 28.76. Perfect. You can see here a graph is going to start to form automatically. You're just going to do that all the way up until Q2 is at 10. All right, so moving on, the next one, what we're going to be doing is we are going to be changing the distance between the charges. So this one, we want charge 1 at 4, we want charge at -4, and we want charge 2 at +4. Right? Now it says we want this Q2 all the way to the left. We'll move it as far left as possible. Now when you do that, it's sort of hard to see, but that means that there's at 1.4 centimeters away, right? Because they sort of get in the way of each other. You can't get any closer than that. That's like the starting point, all the way to the left. And what you're going to do now is just you're going to put the force. So this one is 733.678. You can see that it'll round it automatically to the nearest 100th. Yeah. So then what we're going to do is move it out to 2. Right, so you move it all the way out to 2. It's kind of tricky because it does go every 0.1 centimeter. So you got to make sure it's lined up, or else it's not going to be correct. When it's at 2 centimeters, 359.50. And you can see that a graph is going to start to form now. Now, one thing to note is that the scales for the distance is a little bit tricky. You can see here that it's 1.4, then 2, 3, 4, 5, and then it jumps all the way to 10, right? So instead of just doing a bunch of 10, we just skip from 5 right to 10, but the graph will account for that. Now the next one is just changing the different charges. So we're moving, so it's already on the centimeter mark. We want +4. There we go. +4 and +4, right? So we want them both at +4 microcoulombs. There we go. So in this one, it's pretty easy. What we're going to do is we're going to match the charge in that. So Q1 is at positive, Q2 is at positive as well. We want to tell whether you do have a choice. The reaction is attract, repel, or no reaction. So you can see here that they're repelling away from each other. And the reason why I put them this close is so you can see the arrows. They're pointing away. They are going to repel each other. Now it doesn't turn green because you do have to get them all correct. The numbers of the charge don't matter so much. See, I could even make charge 2, but what we want to know is if they repel, attract, or if there's no reaction. So the next one is going to be 0, and there's no reaction, right? Charge 2 is at 0. There's going to be no reaction. And then the next one, we make charge 2 negative. I'm going to make it -4 just for sake of, just because it's always at negative or +4. But you can see here that now that they are attracting each other, right? So you're just going to do that for all of them. Go down the list, and once you get them all correct, it will turn green. So the conclusion questions are basically asking, okay, great, let's look at the graphs. Tell me, well, what kind of graph does it look like, right? Which type do they look like? And what is the equation? So the equations are on these graphs here, but we just want to see the relationship between the force and the charge, and the force and the distance between those charges. So then the other conclusion questions sort of ask about the graphs, but also what happens with the opposite and same charges, like that fundamental rule of the law of conservation of charge. So once again, this is the simulation, Coulomb's law.